to raise any issue, you know what to do. You can either raise up your hand or just contribute or ask what you want to ask there. But it's good to first raise up your hand. If I fail to pick you because I'm in the presentation mode, then you know what to do. So what I was talking about is C# methods. I'm sure we've done functions in C programming, we've done methods in C++ and in Java. So when you are talking of a method, you are just talking of a block of code which does a specific task for you, right? So the one that we're calling function now in C#, we just call it a method. So it's just one thing, but only that we've changed the name, right? So a method is a block of code which only runs when it is called. So you can pass data known as parameters into this thing that we call a parameter. And the methods are used to perform certain actions, and they are also known as functions. So it's just a way of grouping those statements together, which does a specific task for you. So why do we need methods? Mostly to reuse code. So you just define the code once and then use it many times. So whenever you want, you just need to call that method and then it does the task for you, something like that. So how do you create a method? So a method is defined in the name of the method followed by sorry, it's defined with the name of the method followed by the parentheses and then like this. So C# provides some predefined methods which you already are familiar with, such as the main method. This one also comes with the C#. We've got the console one. Also, it's a method that we always call when we want to print something, the read line, whatever. All those methods are predefined. So normally we've got this method. Okay, this one's just how do you create a method? There's static void, my method. There's a specific meaning there by the keyword static there. I think we need to talk about that as well. So this one will be the name of the method, and then this one means that the method belongs to the program class and not to any object of the program class. So when a mark it is static, it means that that thing belongs to what? To class. I think we've talked about this before when we're talking about when we're doing Java. If you mark anything static, know that it no longer belongs to an object, but it now belongs to what? To the class. And then void means that this method does not have a return value. So in other words, it returns nothing, right? So how do you call a method? Call a method just like putting its name, then you put the parentheses, then you terminate. So for static methods, you do not need any object, but for those which are non-static methods, you need an object for you to be able to call that, right? So maybe for me to say what I'm maybe to try to demonstrate on what I'm saying here. So this is already a method that comes the main method, which is the entry to our application or the entry to our program, something like that. So if I want another program, let me have maybe here, let me just have a simple method here. Let me call it static void. Let me say print detail, something like this, right? So here I'm just, if you look at, I've created this method. So what I'm going to do is, I think I need someone to actually admit those who want to join. So here I will do maybe say maybe printing details, something like that. Okay, so if you look at it, I've created a method, and this method, its specific task is to print specific details. And because I marked it static, for me to call it, I'll just call it straight away. Without the need of anything, I can just call this method just like this. So if I run this, it will print that printing detail, something like that. Why? Because I've created a method to do the task for me, and the task was to print to screen. And then I have to call it for it to run, right? So I think, yes, so I get these printed details. So basically, that's how you create a method there. That's how you call it. But this one, it's just happening like this. Why? Because I've marked it static. If I remove the keyword static, which means this one no longer belongs to a class, but now belongs to the objects of this class. So whenever you want to call this, now you need to to create a new object, right? So we talk about objects later, but allow me to create an object of class program. I think we've used to do this in Java. And then for you to call this now, you need to write the program. Um, don't worry about it. I will talk more about objects later. So if you do this now you can call this method and do this. So whenever you call a method without using the object, know that that method was marked what static, something like that, right? So I think that's what you really need to get to know and to get to understand when it comes to methods. I don't know if there's some that I missed. Okay, so also you can pass parameters to methods, right? You can pass parameters to methods. So when it comes to the issue of parameters, maybe you want to do a certain task, but for you to do a certain task, you want some data, right? So that data that you want, we pass it as arguments, right, to the method, something like that. So you need to create a method with the parameters, and then at runtime, when you're calling the method, then you pass what you call parameters, something like that. So that's what will be happening here. So there's what you call parameters, and then what you call arguments. I think you have been these are things that you've been hearing from C programming, C++, Java, we've been talking about. So information can be passed to methods as parameters, and parameters X as variables inside the method. So they are specified after the method name inside the parenthesis, something like that. So like this one, it was with this string name, something like that. So like this one, it was printed details, but there there was nothing that you were passing here, right? So maybe the details that I want to print is actually a name, right? So here I'll be passing this string name. And then what do I want to do here? I want to print the name, right? Instead of saying the printing details, then I'll say name, something like this. Then I'll put name there, something like this, right? So if you look at it, when I'm calling this method now, it's saying that I need to pass a parameter, I need to pass an argument here. Why? Because here there is a parameter here. So I think it's very, very clear and very, very simple, something like that. So what I want to do is to print this name, right? So I'm passing a name. So I'm supposed to pass a name. So here, let me just pass this name. So what happens, this one is our parameter and this one is our argument. So when you're creating the method here, you put the parameters, and then when you are calling the method, you put what you call arguments. And these arguments are the ones which are going to be matched with the parameters that you have put here, something like that. So if I run this, you find out that it is going to print that the name is what is Ezekiel there, something like that. So that's what you will be doing there. So you can put as many parameters as you want there. Maybe I would say int age there, which means here now when I'm printing as well, let me put age as well. And then what do I have to do there? And then let me put the edge there, something like that. So when I'm calling this one as well, it's saying that I'm supposed to pass something else. So maybe let me put 40 there, and then let me run this. I'm sure you get the name Ezekiel, then edge 40, something like that. So I think this is the basic ways that we have been used to do. So what it does, it matches the arguments that you are passing with these parameters, this one with this one. So if it happens that you switch these two, it will be looking for a method which will be taking an integer first and then a string second. So you will get an error there. It is not going to work if you try to do it that way. But otherwise, these are methods. I don't know if I've got something that I've missed there, but otherwise, those are methods. Then there's the issue of default parameters. Yes, you can use default parameters as well with the C#, where you would like when you call the method, maybe you didn't put a value there, then the default parameters will always work. Like here, if I say, then I'll put the name is maybe Taura, something like this. And then here I'll put the age is maybe 30, like that. And then when I'm running, if I run this, what happens is that I will get this Ezekiel and 40. Why? Because when I was calling this method, I've actually passed the data, right? I've passed these arguments. But what if it happens that you didn't pass the edge? You only pass this string, right? So what will happen there if you do this? Then you see that it will give you Ezekiel, then edge to give you what that. So what does that? It will take this default parameter that we have put here, this, and then it will use that. So it's good to give the default values or the default arguments for your method as well, so that if you fail to put or to give it a value, then what it does just takes what's already there. So it will be better. Why? Because you'll be putting the values that you know it's not going to mess around with your code or something like that. All right. Then there's the issue of the return values. Here we've been worked with the void, which is returning nothing. What about you want your method to return an integer? What about your method you want to return something else like a string or so something like that? So what you do is instead of just having a void here, you can return something that you want to return. Let's say, for example, here, what do I have here? Let me say I have string name, and then let me say Ezekiel, like this. Then here I want this one to, so what I want to do is I want to remove all these. I want to call this method, but okay, what I want is for this to return a string, right? So I want it to return a string. So I want to remove all this because it's supposed to return a string. That's why I'm getting that error. So I need to return a name, right? So by doing so, I'm returning this name, this field, right? So like what you used to do in Java, I'm sure you can also use this keyword as well. It can work just like what you used to do in Java as well. It can work. But by doing so, it is just taking this. So you can just leave it like that. There's no problem. Okay, so after this, right? So this one's going to return a string. So because it's going to return a string, so I'm going to print that using the console, right? Okay, let me remove this. So here I'm just going to print. So it will just print or something like that. Why? Because this one is going to return a string, and that string is this variable name. So it is going to take this value and then it will print it just like that. So I think it's very, very simple and very, very clear there. So you should have printed so you can use a method to do the operations that you want, and then after the operations, then you return a value. Just like if you want to add numbers or so whatever, something like that, and then after that it will return the result or something like that. So you can replace this string with some of the data type that you want to return. If you want to return an integer, then you say int, and then now we are getting an error because we're trying to return a string, but this one is supposed to return an integer. So I think you can play around with all this and try to understand what's happening there. For now, let me just return a 0 there. Okay, so that it will return an integer, so we do not have an error there. But otherwise, that's all just think I'm just trying to say if there's anything that I've missed there that you must appreciate, but otherwise those are the basic things when it comes to methods there. Okay, also there's the issue of named arguments. For example, if like when I put two arguments, I've said that if you switch them, then you get an error. Like here when I was having the name and the age, and I said that when you're calling it, if you do not pair them very well, you are going to get an error. So to avoid that, what do you do? So you name the um what do you call it? When you, these are parameters, right? So when you are now passing, then you provide the name so that it will be no longer necessary to match the order there. So if you say child 3, then you put John there, then child 1, then here you are putting Liam, something like that. So now what does it do? It will take this value and go and look for the parameter named child 1 and then put that value. It will take this one, go and look at the parameter name child 1. So it will be matching the arguments with its parameter by just look at the name. So you are no longer need or required to match those things, something like that, right? Then there's the issue of method overloading. We've been talking about this when we're doing Java, that there's method overloading. We talk about polymorphism, where you're having same method doing different things, something like that. So when it comes to method overloading, we are having the same method, but this same method is being overloaded or is being made to do more than just one thing, something like that. So with the method overloading, multiple methods can have the same name with the different parameters. So what does it mean? Or even with a different return type as well. So you'll be having the same method doing different things, something like that. So like this one, my method, if you look at taking an integer, this one's taking a float, this one's taking a double, and then this one's returning a float, this one's returning a double, something like that. But if you look at it, the name is just the same. So you can have a method or methods with the same name, something like this, but different parameters or maybe different return type. But if you match the return type, the number of parameters and the order or something like that, then it will be now method overriding, something like that. It will be different from the method overloading or something like that. So I think those are some of the things that you really need to understand it there, right? So let me, I hope I've accepted everyone. Okay, Linda wants to join. Okay, so let's try to have an example on this one. Okay, let's have a method there called, let me just say, add numbers. Okay, so here I'm going to take int a and int b, right? So what I'm going to return is a plus b, something like that. So I want to accept, someone wants to join. And then now let's have a double one. So what I'm going to, I'm just going to copy this just to save time. So I have this one, and then I need to call it, it needs to return double there. And then because here the return type, now let's put double here. So that we will do match the return type. Otherwise, we were forced to, to cast the result, because if you put integers there, you add integer, you get an integer, but it's supposed to return a double. So we're supposed to cast it. You've been talking about casting there. You are supposed to maybe to wrap this right inside brackets, and then also here we're supposed to cast it to to double, something like this. I'm sure it will work this way. Then so if you put an integer there, I'm sure it will, and then you have an integer there, I'm sure it will work that way. It's not going to work. Okay, it's because of the issue of same number parameters. It's not about the return, it's about the issue of parameters here. So it will be not knowing which one am I supposed to, because these are integral numbers. Okay, I got it. I got it. So you need to make sure that these are not, unless if you want to do method override or something like that. So to avoid complexity and everything, let's just remove this. Da 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 da. So you can have as many methods as you want with this name, add numbers, whatever. So what you need to do is to make sure that these are not the same with these parameters that you are going to have here, and maybe also the return type, something like that. Otherwise, that's it with the method overload. You can have the other one, which you take maybe 3 numbers or maybe 4 numbers or something like that. Like here, if I can take this and then maybe I would give it another double C there, and then this one I'll edit something like that. So this is what you call method overloading. It's one method with the same name, but doing different things. I think it's very, very clear. So what do I do here? Now I'm calling the method using this object. So I will say add numbers, something like that. And then I'm supposed to pass, right? I'm supposed to pass a value. So if I want to add just 2 integers there, so this is the function, or this is the method which is going to be called. So there I will put 30 there and 40 there. So I'm expecting to get a result 70, something like that. So if I run this, you'll find out that I'll get a 70 there, and it will be in this one. And it is this method which is being used. That's why I see there is one reference there, like we've called it once, something like that, right? So at runtime, we know which method is going to be called, something like that. Not at runtime, sorry, at compile time, we know which method is going to be called. So it comes to the issue of polymorphism. This is the one that we call compile time polymorphism. Why? Because at the compile time, like now, when you're compiling, before even running it, we know that this is the method which is going to be called, something like that. So if I copy this as well and try to call the second method, so what I'm supposed to do here, I'm supposed to pass 2 double numbers there. So here, let me put 40.6 here, maybe 0.80 there. And then if I run this, find out that it's going to give me 71.4 and this one 70. So I can also code this by giving 3 numbers, so it will call this one as well, something like that. So basically, that's what you do there with method overloading. Otherwise, let's look at the concept of object-oriented programming, at object-oriented programming concepts. So on object-oriented programming, this is what we've also covered when we're doing Java. So here is as good as we are repeating the same thing. Very, very same. Like it's just the same thing. Nothing different that we're going to talk about. The concept is just the same. So if you look at it, OOP stands for object-oriented programming. So there's the one that you call procedural programming, the function-oriented programming that we used to do in C programming, not in C++. C++ is also an object-oriented programming concept, but object-oriented programming language, but only that when you were doing that on data structure, whatever, something like that, you didn't go deeper to classes, inheritance, whatever. But trust me, it's there in C++. You can create a class in C++. You can do inheritance in C++, something like that. So all these concepts are borrowed from C++. Okay, so the procedural programming is about writing procedures or methods that perform operations on the data, while object-oriented programming is about creating objects that contain both the data and methods. So if you look at it as C programming, we'll be talking about creating a function, and this function, you've got some data there that it will be working on. But when it comes to OOP, we are looking at having classes and creating objects of that class, and this object now will be having methods and those fields or those data members. So now we are now working on objects. So now we have objects that will be working on the data and the methods or something like that. So it's no longer about having methods or functions working on data, but now we have the data and the methods being contained in one class, right? And then create an object of that class, and that object we just inherit the data and the methods. So when you have an object, you can now do the operations on the data by just calling a method, something like that. So object-oriented programming has several advantages over procedural programming. The first thing is that OOP is faster and easier to execute, and OOP provides a clear structure for the programs. If you look at it, you always know that you'll be having a class, then you'll be having the fields, and then so here we call them fields or those data members, something like that, the variables, something like that, and then we have got the method, something like that. So OOP helps to keep the C# code dry, like we say, don't repeat yourself. So makes the code easier to maintain, modify, and also to debug there. OOP makes it possible to create full reusable applications with less code and shorter development time. So basically, that's why OOP is superior to procedural or to function-oriented programming languages or that paradigm. So what a class is and what are objects, right? So when you talk about OOP programming languages, you'll be talking about classes and objects. So a class and objects are the two main aspects of object-oriented programming. So looking at the following illustrations, if you look at it, if we've got a class called fruit, the objects will be apple, banana, mango, or those instances or those examples of fruits, right? So it's just the same if we've got a class of a student, right? And then which means the objects that we will be creating are the actual students, which means it will be you, right? Will become now the objects of that class. So if you look at it, this one now related to the actual world, right? When you're going to create a system, when you're going to create a software, you create it for actual world, right? So if you now have like a prototype, or when now we have programming languages which mimic the real world, it will now become easier for us to create systems for the what? For the real world. All right. Think of a project that you want to create which will be managing these fruits or something like that. Now you'll be knowing that we are going to have a class of fruit, and then you are going to create an object which will be looking at apples, something like that. So whenever you want to deal with apples, whatever, you go with that, the object of apple, whatever, then for banana, something like that. So it will be now having that touch with what is happening in the real world, something like that. So if you look at this class car, we can have a Volvo, Audi, Toyota, whatever, BMW, something like that. So basically, that's what will be happening there. So when you're looking at a class, you're looking at a template for objects, right? Why? Because each and every object that you can have, it will be containing the data that and the methods from that specific class. So an object is an instance of a class. If you are being asked to define an object, it's just an instance of a specific class. So when individual objects are created, they inherit all the variables and the methods from the class. If you look at here, I've said that I'm creating an object, and I said we are going to talk about it. Yes, we're going to talk about it. But if you look at this object, it's the one which we are using to call these methods. So this object will be having everything which is inside this class. If you look at, if I'm saying everything which is inside the class, I'm talking about everything. So this is my class program. So which means this object will be having this field name or this variable name, as well as this all these methods that we have. That's why I need this object to call all these methods and also to access this field or something like that. Otherwise, I need to make it static so that it will belong to a class or something like that. So when I look at an object, it's just the object will inherit everything which is within the class, right? So now let's look at the issue of classes and objects. I think I've talked about this, but when I'm creating a class, I think we've been creating the classes, just use the key word there, class there. I think we've been doing that in Java. There's no need of really mentioning this, but this is how you do it, class, and then you put the class name there. Also, class can be marked. We'll talk about it when we're talking about the access modifiers, private, public, protected, or something like that. So here we use the term fields there for this one. It's a field. We call it a field, or these data members, right? We call them data members or attributes as well. We call them attributes as well, like this one. We call them attributes. Why? Because these are the attributes that describes the class car. Like here, I've got a car, and the color of this car is red, something like that. So these are the data members or are the attributes. So we normally call it a field. So here, that's where you put your fields there or the attributes of that class. And after that, you put methods just like that. So here they were showing you how to create an object. There's really no need of defining a class. I think we've already done that. And defining an object, we've already done that. So here they were showing you how do you create an object. So this is what we've been doing in Java. We've been creating objects of a class by using the new keyword and the construct of that class. Like here, I've said the program, which is this exact as the class name. So I will give it the name that I want there, right? So here I will say program maybe P1, then I will say equal to new, then I will use this new keyword, and then I need to call the constructor. So it's program like this, and then I'll be good to go. So now I've created this object, and this object have got everything that this class have. That's why you can see that I can say p dot, and I will be able to call this add number there, and maybe I'll also be able to call that name variable. If I do this, you see, I can have it there and do whatever I want with it, something like that. So that's what it is on how to create an object there. Also, there's this way. I'm sure there's this way in C# where you could use this var keyword there. If you do this, what it means is that you are telling the compiler that I'm going to have a variable here called P1, but you are going to detect its type automatically, something like that. So instead of saying int, something like that, int, string, whatever, you can define all this by using what var, something like this. So whenever you do this, the data type that you put is the one which is going to be used to detect or something like that. So this one, you can use it only with, not with the fields. You can use it with the local variables, like here I'm inside a method, something like that. But basically, that's what I really wanted to, like here I can have a variable, maybe farm A, then I'll put a 20 there, something like this. What it means, this A will become an integer just because I've put 20, so it will automatically detect that this is an integer, something like that. So I just thought it is worth mentioning it. You might see it being done somewhere, so it's worth mentioning it. But otherwise, this basic way that we are used to do, I think it's always good, because it really shows you that this variable is of type class what program, something like that. So this one it's an object. It's not a variable, but it's an object. So that's how you create an object. Let's look at the issue of multiple objects. If you want to create multiple objects of a class, you can do so. So you can, it's not like you can just declare one object. You can declare as many as you want. You can declare as many as you want objects here. Just like that. I can copy this and put, is that a contribution or what? So here I can put maybe program 2, maybe here, or put it 3 here or something like that. Just like that. So you can create as many as you want there. There's a hand by Sherry Swarowash. You want to ask, is it a hand for a question or?
It's a hand for a question, say.
Okay.
Ama-objects abonakala mchana. How to create them, how to know that this is an object.
Okay. Thank you for the question. Okay, so what we are saying is an object is just a variable, right? Of a type or a class, something like that. So it's as good as when you're creating a variable, right? Or when you're declaring a variable, you can just say int a, right? Just like this. But when you are now creating an object, both this object is also a variable, but it's a variable of a specific type, which type of a type class. So instead of say int, because it's not an integer, we say the name of the class. For this class, it's a program. So we say program, something like this. Then we give it a name, right? So we say maybe P1, something like this. So after doing this, we need to call the constructor of that uh, of that class. So you say new keyword there, and then you repeat the same as the class name. Why? Because a constructor, we talk about constructors later, always carry the name of the what? Of the class, something like that. So when you're creating an object, you use this new keyword. So you say the name of the class, then you put the name of the object or a reference variable for that object, something like that, and then use new keyword, and then you call this constructor, or you just repeat this the name of the class, and then you put these parentheses. Then after doing so, you have created an object. This what P1, this P1 is now an object. And like what we have said, an object will inherit everything which is within this class. So this P1 will always have everything that we have in this class, and we're able to do whatever this class is supposed to do, something like that. I hope we are answered there.
Yes, thank you, sir.
Okay, you're welcome. So basically, that's how you create an object there. Now let's look at the issue of class members. Some of the things I think I've already talked about it. So what I will do is I will just try to be quick so that um, we finish this early. Okay, so fields and the methods inside the classes are often referred to as class members. So when we are talking about class members, we are talking of these two fields. We are talking about what you call fields and methods. Why? Because those are the things that you can put in a class. What are the fields? Fields are the attributes or those variables that you put inside a class but outside of any method. So any variable that you are going to put in your class but not inside the class but not in a method are going to be called what? Fields. In Java, we call them instance variables, but in C# they decided to call them fields or just attributes, something like that. So I think the best way is to just call them attributes. Why? Because these are the ones which it describes the what? The class, something like that. Like here, if you're talking of a car, so you'll be saying this car is of color red, its maximum speed is 200 kilometers per hour, something like that, right? And then the method now full throttle, this is the method which will be called whenever you put your leg maybe full on what? On gas or something like that. Just something like that. So we are going to have methods and fields as what? As class members. I think that's all that we can talk about. I think we have already done the declaration of fields here, like here when you have string name, and also having all these methods that we have created here. So those are the class members. I don't know if there is anything that I've missed, but we've created objects. Maybe let's just quickly talk about constructors. But if you really need something, guys, please just stop me. So let's talk about what we call a constructor. A constructor is just a method, right? So maybe the question is, why now being called a constructor? It is just a method. We've got this main method. It's just a main method. So why now calling this method a constructor? So a constructor is that method that we use to initialize the variables with the default values that we want to be used whenever we do not initialize, or maybe whenever the objects are being created. Right? So whenever you're creating an object, I think you have said that you are going to call a constructor. So that constructor is a special method, which you are going to use to initialize the values for the fields whenever the object is being created, something like that. So because it's now a special method, there is a special way as well of creating it, which is different from the ways that we've been talking about when we're doing methods. So how do you create a constructor? It's just the same as we used to do in Java there, but let me try to clean my code so that we will not have a lot of things here. I'll try to, let me just remove everything. So I'm left with, so if you look at it, so I want to remove this. So I've got just a name there. So what happens is, if I want to create the object of this class, let me say program fambisa pano zvakuda kutaura. Let's make sure that you are always muted there. Okay, so program, want to say program, maybe P1. So when I say here program, then like this, I'm calling a constructor there. But what happens is, because I didn't create any constructor here, so C# is going to give you a default constructor. So what you call a default constructor is just the constructor which will be created for you if you do not create any constructor. And that constructor is just the constructor which doesn't take any argument there or take any parameter there, something like that. So that's the one which is going to be used there. So if I try to print this, then I'll say p1 dot name there, try to print this, and let me try and see what happens there if I do this, because we've got the default constructor which is going to be created there. I'll get nothing there. Why? Because I didn't try to give this one this a value when I was creating an object there. And the default constructor, what does, it's not going to put anything there. So it will have a default value, something like that. So it will just put the default values, and for a string, it's just nothing there. So maybe for integers, it will just put a 0 there, something like that. So how do you create a constructor? You just need to use the name of your class, the name of the class, like the class is what is program. So because it's a method, it will be having this just like a method, something like that. So it's not going to return anything, even a void. So we are not going to say static void, something like that, or maybe int, something like that. It's going to return nothing there. So we are not going to give it anything there. So maybe now I can just put the value there, maybe something like this. Then I would say maybe Ezekiel there. So, or maybe instead of, yeah, let me just say this. Okay, let me just say this. So when now I call this, what will happen there? I'm sure it's going to put what Ezekiel in that, something like that, right? So also, before doing this, maybe what I will do is to show you that when you're creating the object, so I've commented this out. So if I run this, I'm sure we will see a blank. Why? Because there's nothing being happening there. We are printing nothing there. So I want to take this out and maybe print out that new object was created or whatever, something like that. New object are created. So whenever we are creating a new object, we are calling this constructor, and this constructor is not taking any parameter, which means this is the constructor which is going to be called when I'm creating this object P1. So if I run this, it's going to call this constructor. So it's supposed to print that new object is being created, something like that. So you see new objects being created. So because it's calling this, now we can give the values to this object P1, right, to the attributes if you want. So if P1 is maybe for a student called Ezekiel there, then what do you do there? You just need to give the value there. Maybe, sorry, I need to accept those who want to join. So what I will do there, maybe I'll just say, sorry, I'll just say name. So name, then I'll put what is equal like what I did, right? Something like this. But this is not the best way because each and every object which is going to be created is going to be given name Ezekiel, something like that. So what if you want to do it specifically for each and every object that you are creating, then you give it its a specific name. So what it means is that you need now to pass a parameter here. So it's no longer a default constructor there. This one is now a constructor which will be taking what parameter. So we call it a parameterized what constructor. So here I'll be maybe saying name here. So this one is the variable that I'll be passing. So here, that's where you need to use this keyword, this keyword. So what I will do there, if I do so, if you look at it, so there will be a confusion. Which name do I mean here? So this name is just this name that we have and this name that we have. So it doesn't make any sense. But if you say this dot, what it means that this one now will be referring to this field, right? Or to this attribute that we have here. So now what happens is that when now I'm creating the object, now I'm supposed to pass a value. Like what we have done with the methods, when you're creating the methods, when you're doing overloading, whatever, something like that, we would pass an argument. So here I'm supposed to pass an argument. So whenever I'm creating a new object now I'm sending the values, then it will be sent to this attribute. So this P1 now on its name now will be having what? Will be having the name is Ezekiel, something like that. So if I do this, I'll get this. So whenever you're creating a new object, if I create another object, maybe let me say just a program, just like this, and then I'll say P2, then new program. Then here, what do I do there? Then maybe I'll say I'll write something like that. So what happens is that this one now we have its own unique name, but we are just using the same constructor, right? So if I take this and run, so I just want to duplicate this, and then here I'll put P2, something like this, right? So if I do this, something like this, you'll find out that I'm going to get then this and this, something like that. So basically, that's all about constructors. I don't know if there's anything that I've missed there, but otherwise, I'm sure that's everything about constructors. You can go and read, but otherwise, that's the use case of a constructor. And also, that's the default constructor and the parameterized constructor that we've talked about. Also, there was the issue of overloading a constructor. Why? Because the constructor is also a method, right? So when you're doing method overloading, You see what we've done? You can also do the same. Here I can also have different constructors, like here, program, and then here. So now I'm having a default constructor which is taking only one parameter. I can also have a constructor taking 5 parameters or something like that. So it's now method overloading. Why? Because it's just the same method but doing different things or having different number of parameters, something like that. So you can also do the same with what? With the constructors. Only that now when you are calling, that's where you need to specifically pick the actual constructor that you want to run because of what you pass here, something like that. Because here I'm passing a single argument in it's a string, so it's calling this constructor. That's why there are 2 references there. But here there's 0 reference because apana parameter call a non-parameterized what constructor, something like that. So I think it's clear on that. Now let's look at the access modifiers. Now let's look at the issue of access modifiers. So when it comes to access modifiers, I think we've been talking about this. There is the public, there is the private, there is the protect, something like that. So these access modifiers are used to set the accessibility or the access level or the visibility for classes, fields, and the methods, as well as what, as well as parameters, as well as properties. So there is this public. So when you use public, the code is accessible for all what, for all classes. And when you use private, the code is only accessible within the same class, right? And when it's protected, the code is accessible within the same class or in a class that is inherited from that class as well. Also, when you use the internal there, the code is only accessible within its own assembly. When I talk about assembly, I talk about the project within its own project, but not from any other assembly, something like that. So these are some of the access modifiers that we have. But you might have where a combination of protected internal and the private are protected as well, something like that. But these are the basic access modifiers that we have, and you can apply them to classes as well as to our variables. But I think there's something that is really need to understand as well. The issue of private, public, especially when it comes to classes. There are some areas where you could not use them just because it doesn't make any sense to mark it, maybe to mark a class private or something like that. We'll talk about it maybe later if there is real need of it. But here, if you look at it, we can make this private. So if you make it private, it's only accessible within this class. Outside this class, you cannot access it unless if you do the issue of having the public getters and accessors, whatever, something like that, the setters and the getter method, or something like that, to access that. It's just a concept of OOP. You talk about it later, right? But basically, that's what it is. So here there is an error that you could not access this module. Why? Because module is private in this class, and you are trying to access it here inside this class. It's not going to work, something like that. So you really need to be aware of this. So you can experiment with these access modifiers to see how do they work here. Like here, you can mark it private, or maybe you are marking it public, or something like that, or you're marking it what? Protected. So it have got a meaning by saying so, it will have a special meaning by doing so, or in terms of visibility and accessibility, something like that. Leaving it like this, it will take the default one, which is the internal one, something like that. So that's what it is. That's what it is. You can go and experiment with this. Then there's what you call properties. Let's talk about the issue of properties. So I think this one is it's a very important thing when it comes to object-oriented programming. Why? Because this is the best way that we can achieve what we call encapsulation, right? So what is this encapsulation? Like what we've said in Java, we're talking about encapsulation. This way you try to hide the sensitive data from users, something like that. So that if there's someone, maybe we are looking at a setup that maybe you are programmers there, someone given a module, and maybe you're working on the same system there, something like that. So you do not want people to just come to or to access your code and change things, right? But what do you want to do? You want to have that control to give them either the read only or to write only, or both read and write on your data, something like that. So how do you achieve that? You achieve that through what you call encapsulation, making the fields private, and then provide the public getters and the setter methods through what we call properties to access and update the value of a field, something like that. So in Java, we used to create the public get, maybe public void get, no, not a void, maybe for getters, it doesn't need to be void because it's returns something like public string, then get name, something like that. We could create methods, but here it's not necessary to even create methods for that. You can just choose what we call properties, and there are some rules to it. So you learn from the previous chapter that the private variables can only be accessed within the same class. So in outside class, there's no access to it. So however, sometimes we need to access them. So, and it can be done with what? With the properties. A property, like a combination of a variable and a method, it is two methods, a get and a set, something like that. So this is what you'll be having there. So because it's a property, you are not going to have to put the parentheses there, something like that. So let me just take this, or we already have what do we have here? Okay, let me just so this one is the one that you need to mark private there, right? So let me just take out this. We no longer need all these constructors, all these things. Let me just try to take all these things. So what you want to do is to have the property there to set or to get that value. So because it's a property that you want, so it needs to be what? It needs to be public. That's the first thing. It needs to be public. And if you look at it here, the next thing is the data type of that, and then this one needs to be a capital letter rather than to be the same as this one. So you normally put the first letter of that property, of that field, whatever, as a what? As a capital letter, something like that. So because you have got a string name, this one, so here what do you do? It's also string, but now we put what? We put name, something like this. And then because it's a property, you are not going to put what? So because it's a property, you are not going to put so we are not going to put those braces for the parentheses for a method there. So the next thing is to provide the get, and as well as the what? The set there, the set method. So this will be helping you to now get the name there and set the name, something like that. So you can now use this property to get the name and the whatever to set, as well as to get that from another class, something like that. So the best I do was to have a class here, maybe class, and then maybe call it car, something like that. And then maybe inside this class now, let's have a string there, but instead of maybe let me just say name there, and then we provide these getters and the setters in here, something like that. And then what do I do there? So we no longer need this, right? Let's remove this here. So this one needs to be private there. This one needs to be private, something like this. So after doing this, now what do I need? So I've got this class here. I made this private, which means I cannot directly access that inside this class. Like here, if I create the CAM object there, something like this, I've created this car object, and then I'm trying to access car dot name there. So if you look at it, I can only access the property, not the actual variable, right? Not the actual variable. If I try to put this, the actual variable, I'll get an error for one good reason. Let me just say BMW there. For one good reason, I will be not able to access this private field. So look at it as that way, that you are now controlling who is going to read, who is going to write, by either providing either a get or a setter, a public get or a setter property, something like that. So if you just want that person to be able to just get the value without being able to change it, you remove this setter part. You only put the getter part, something like that. So here, how do you do that? If you want to set the name there, now you say car dot name, you use the property just like that. So after doing this, what happens that this name is going to be given the value at BMW. So if I now want to print it, I would say car dot, I will use the get. Now I will use what what do you have here? I'll use instead of just using not get sort, I'll use the property there. So I use the property. If I do so, then I'm sure that it will give us the name, something like that. So it now does that implicitly. Now it knows that now I'm supposed to give a value. Now I'm supposed to set the value, something like that. So if you just say car.name without providing a value, it will call this get name there, and it will return the name there. That's why we have seen BMW there. But if you give a value there, it will automatically go and assign the value to what? To this name, this one, just like that. So that's what will be happening there with the property there. So I think we've covered now the the encapsulation. So now I think you know what is encapsulation and how to achieve encapsulation, and maybe why do we really need it, right? I think we've seen that we can now control, we can read, we can write, now we can hide the data in a fashion or in a way that we want, something like that. So now let's talk about inheritance, right? How do we do inheritance? I hope we can really try to finish this early. So on inheritance, I think we've been talking about this as well in Java as well, right? That when you're talking of inheritance, that's when you are looking at now there is code which is already there, but we want to make use of that code, right? We do not want to rewrite that code. So what do? We just inherit it, right? Something like that. We just inherit it from those classes which have already implemented that code. So maybe we've got a new class, and that new class we've got some methods that it needs, and this method is already defined in another class. You can just inherit it and make use of it. Very boom, you are good to go, something like that. So that's where inheritance come in there. So in C#, it is possible to inherit fields and methods from one class to another. So we group the inheritance concepts into two categories. There is what we call a derived class and a base class, like what we used to say in Java, super class, whatever, something like that, a super class and a base class or something like that. So when you're talking of a derived class, is now the child class, or the class which is inheriting from the what? From the base class. So the base class is the parent class, something like that. So to inherit from a class, we use this 4: symbol. It's now different from Java, where you would use extends keyword, but here you'll be using this what? This 4: or this symbol. So in the example below, the car class, which is the child, inherits the fields and the methods from the vehicle class, which is the parent class. Like here, we've got the vehicle class. And if you look at it, car, then we've got this 4: here, which is inherits from what? From vehicle, or is being derived, or a car derived from vehicle, something like that. So what happens is that because this one is public, if something is public, it can be inherited, something like that. But if you make it private, you know what happens. You cannot access those members. So when you do that, it means that this brand will be already now part of this class. You've already inherited it. Even this method hog here will be already part of this car class. So whenever you are calling the car, or whenever you're creating the car object there, it will be already having this method. But this method, if you look at it, we have created inside this class vehicle here, not inside this class car, but you'll be able to call it from the object of a class what, of a class car, something like that. Why? Because we've inherited that. So that's the importance of inheritance there. You'll be no longer needed to actually use that method. Not you are no longer need to recreate that method, something like that. So that's what it is there. That's what it is. If you want to prevent a class from being extended or from being inherited from, you just use a sealed there. If you say sealed class, that class, there's no other class which is going to be derived from that class, something like that. You cannot inherit from that class with this keyword sealed. Okay, so that's it there with the inheritance. I think you can go and play around with this. I don't think there will be any issue there with this. Like I've got this class card there. If we would want there, we would do what? This program, maybe something like this. What it means is that now by doing so, this public method here, the string name, whatever, this one will be there. But maybe if we mark this public as well, by doing this, marking this public, what it means, we do not have a string that we have created here. So we do not need the car object for us to be able to access name there. We do not need that because we're inheriting from car there. So what can I do there? I can have an object for program there, P1, just like this. Then I can say P1 dot name there, and then I will put a test there, and then I will just print this, and then I'll say P1 dot name, right? Just like this. And if I run this, you see that I'll get test there. And if you look at it here, I didn't have any name that I've created here, but I'm inheriting it from here. And if you look at it, I would also use the setter and the getter method like it's already in this program here, but it is actually here through, it will be actually here through inheritance, something like that. It will be actually there through inheritance. This one I can call it here. Instead of putting P.1, I can say this one name there, and I can also say this name using the property, the setters and the getters here. And I'm sure it will have the same effect there. Yes, just like that. So that's what it is with the inheritance there. So maybe let me just try to change this one to protected. Let's just play around with this. Da, 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 da. So instead of let me try to access this, yes, I can still access using what? Using the protected there, because here I marked it protected. And if you go to access modifiers, you know what we've talked about when it comes to protected. Otherwise, you can go and experiment with inheritance there. The next thing is polymorphism. I'm trying to do it a rush job just because we have already defined these things when we're doing Java together there. And it's not even last semester, it's this semester. So I think it's just a good revision there. Okay, so polymorphism means many forms. So this one, it occurs. So it occurs when we have many classes that are related to each other by inheritance. So whenever you're using inheritance there's a possibility of you to implement what we call polymorphism, where you would override an existing method, which means we now have maybe one method doing different things, something like that. So like we specified in the previous chapter, in inheritance lets us inherit fields and methods from other classes, from another class. So polymorphism use those methods to perform different tasks, right? So this allows us to perform a single action in different ways, something like that. So there was an example here where we would have a base class animal and a child class called animal sound. So the derived classes of animals could be pigs, we could talk of cats, dogs, birds, and the like. And they also have their own implementation of an animal sound, something like that. as we know that pig, cat, whatever, all those animals could give a different sound. So if you look at it, we would have the class animal, and we've got a method there, which is the animal sound, and then we are just printing that the animal makes a sound. And then we've got this pig, which is inheriting from this class animal. So by just inheriting, so you'll be having this method is already here, right? But now we are overriding it, which means you are now having the method for this as well as for the pig class there, something like that. And then we could do the same again for the dog there. You've got this, but I'm sure if you do this, whenever you are calling, I'm sure it will call the method of a superclass there. If you look at it, let's see, now we can create a pig and dog objects. Okay, let's see what was happening here. Okay, so in this class program, they were now creating this. Okay, maybe because they have already the class program, they are being tempted to take this and just work with it from this side, right? So let me take out this class that I have this class for car there. So let me have all these classes, and then what do I need to do is to just call this, and then we will talk about the output. I just want us to see the output that we would get. Let me remove this. Let's talk about the output that we would get. So if I do this, if you look at it, this was the animal object that was created, and then this was the pig object that was created, and then this was the dog object that was created, and used that those objects to call those methods. The animal sound, animal sound, animal sound. So we are coming for this animal class, and then we call this. That's what we've done here. And then we've got come for the pig class and try to call what the pig, the animal sound method, and also for the dog object, try to call for the animal sound. So if you look at it, here they are saying that hides inherited member, something like that, use the keyword if the keyword new, sorry, use the new keyword if hiding was intended. Okay, so what happens here? I think that's what I wanted to explain when it comes to inheritance. So if you look at it, we are just calling the same method, animal make sound, animal make sound, animal make sound. So there are those who want to join. But if you look at it, when you're using this, my pig and my dog, I think we're not supposed to get that, because for pig, the method is this one. And for that one, the method is this one. So because of polymorphism, we are inheriting, both these classes are inheriting from animal. So it happens that they also have the method from the what? From the animal class. So you need to use override for you to be able to call those methods. So you need to use the virtual and override keyword for you to be able to override the method from the what, from the parent class, something like that. So that's why you see that here when you're creating this method, you mark it virtual, and then you mark it override inside the derived class or the child class. So what it means is that we are now overriding the method that we have inherited, and then in here we are now able to do what we want to do specifically for what? For pig. But we are just using the same method, which is from what? From animal, something like that. So you need to mark it virtual, and here mark it override, something like that. So I think it's just as simple as that. So here, that's where you need to mark it virtual, right? And then here you need to mark it override. Sorry, it's override. And then here you need to mark it override. So if I do this, where you see that now we are getting the actual methods that we really wanted, something like that. So you can go and play around it and see what you get there. Otherwise, what you would want to do is talk about abstraction. I think we've talked about this before in Java as well, where we would talk about the use of abstract classes. How do you achieve abstraction using the abstract classes as well as using the interfaces, right? So there's what you call abstraction in a C#. Excuse me. So data abstraction is the process of hiding certain details and showing only essential information to the user. Now you are hiding some details, but showing only the essential information to the user. So how do you do that? So abstraction can be achieved with either abstract classes or interfaces. All right, so I hope my network is still stable. Okay. So you can either use abstract classes or what you call interfaces. So using abstract classes, the abstract keyword is used for classes and methods, just like what we used to do in Java. So abstract class is a restricted class that cannot be used to create objects. So you are not going to create an object. So to access it, it must be inherited from another class. So you need to drive it or to inherit it from what? From another class. So abstract method can only be used in abstract classes, and it does not have a body. So the body provided by the derived class or the class which is inheriting that abstract class. I think it's very, very clear. These are simple rules. So an abstract class can have both abstract and regular methods. Like this class that we have here, it's an abstract class because it's marked abstract class. This is what it's just the same like what we used to do in Java. So for a method, you say public abstract void, and then you are not supposed to put a body there. So you do not put this block to a method if it is what? If it is an abstract method. And an abstract class can also contain those regular methods that we know which have got a block. I think it's simple and straightforward, right? So that's how you create an abstract class. And I think we've learned about inheritance. And now we know that whenever you are inheriting, everything which is marked public is going to be inherited, right? So I think it's simple and straightforward. So if you are inheriting from an abstract class, because remember I've said that you cannot create an object of an abstract class. So if you're inheriting from an abstract class, what it means that the class which is inheriting automatically become an abstract class. Why? Because it will now have this method which will be available. So for it to be not an abstract class, it needs to implement every abstract method from the class that from the parent class, something like that. Failure to do so, you need to mark it abstract as well. I think it's simple and straightforward. Just like that. I think it's simple and straightforward. How do I have here? Let me just take it this one and I'll demonstrate with this code. I think it's I think it's why do I need that? I think it's very simple and very clear, and it's mimicking what we already have, something like that. Okay, let me take out everything here and put it this one here. Yes, okay. So I've got an abstract class here marked animal, named animal, and it have got this abstract method animal sound. So this pig class is now inheriting from animal, and then there is this animal sound that you are overriding. So I want to show you something. If I remove this one, I will have an error. The error is that this class is inheriting from the animal class, but this animal class is an abstract class, and it have got an abstract method, this one. So this class which is inherited from animal class, it also have the public void slave which you have already inherited, and you can make use of it. But we have also inherited an abstract method. So by doing so, this class is forced to be marked abstract like this. So abstract. like this, and the error will go. Why? Because this class already contains an abstract method. So if you do not want to make it an abstract, you want to create the object of this class, what are you supposed to do? You need to implement every abstract method which is already in that class. I think it's very, very simple and very clear. Otherwise, everything that we do later on applies with polymorphism and inheritance that we've already learned about. So you can now create the objects, but you cannot create the object of animal class for one good reason. It is an abstract class. This one you no longer have the dog class there. So we need to remove everything here and only left with this, right? So this is what is happening there. I don't know if there is any issue with this. I think it's quite clear and quite easy. But if there is any need for further explanation, please, you can ask. Okay, so this is what you can get. Okay, so on the issue of interfaces, I think you can also go and look at this one. Any interface, it's just like what we do with abstract with abstract classes. Only with this one, you cannot create any object of this and not create any object. Yes, just the same with the abstract class. We cannot create objects, but with this one cannot have regular methods. So it can only have abstract methods, something like that. So you can achieve it through abstraction through the use of interfaces. But with abstract class, it's some sort of a mixture, something like that. You cannot have true abstraction through abstract classes unless if you only put abstract methods in that abstract class, something like that. So if you look at it here, I've got this interface with only abstract methods, something like this. They do not have any port, just like that. So that's what will be happening there, this interface, and you cannot create an object for that interface. So I think it's a very, very simple and very clear. So that's it. So when we're using implements there in Java, here we do not use that. We just use this sign for inheritance there. So this was an interface there, and you normally put an I to show that this one is an interface, like this I animal. But it's not mandatory though. It's just a way to show that this one is not a class, but it's just it's an interface. I think you can go and read more on this, but I think I've already talked about the characteristics of an interface there. Maybe the next thing that I would want to talk about before we finish this tutorial is about the issue of exceptions. Why? Because these are very, very important. So when it comes to exception, just like in Java, we use what you call the try catch block. So when executing a C# code, different errors can occur, which is coding errors made by the programmer, or errors due to wrong input or other unforeseeable things. I think it's always good to also go and read about errors and understand the types of errors that can happen in a code, right? So an error occurs. So when an error occurs, C# will normally stop and generate an error message. So the technical term for this, we call it C# we throw in what? An exception, or we throw an error. So how do we make sure that the code will not just, or the program will not just collapse, but maybe to try to tell the user what is happening and maybe do the next task? So what we do is we use the try and catch statement, where the try statement allows you to define a block of code to be tested for errors where it is being executed. And then the catch statement allows you to define a block of code to be executed if an error occurs in the try block, something like that. So it will be working as a pair. So you say try, then you put your code that you think it might throw an exception. And then after that, you catch the exception, which means you try to do something, maybe to avoid the program to crash there, something like that. So there was this one, which was declaring an array. Yes, let me just copy this one, and let me clear everything here. And then if I run this, I'm sure there will be an error. Why there will be an error here? Let's just talk about this. Why there will be an error here? This is an array that I've declared, and I've initialized 1, 2, 3, and I'm trying to access the array here, whatever, and print what I want to print there. What could be the error there? Someone to tell? I was not really checking on the check. I'm not seeing anything. Don't. If I'm the only one, don't know if I'm the only one with the problem. I don't know if you've managed to fix your problem there, but I don't know, guys. Why am I getting this error here?
Because array redu kumira pana 4 zvoroti rutangira pana 0 1 2 3 asi kuswa kuna 10 kwakanyorwa.
Indeed. Thank you for that. So what is happening here is that if you look at that, the index, the array size here, we've got 1, 2, 3, which means the array size here is 3, because we've got 3 elements. And we are trying to access the element at index number 10, which means it will be something at the actually getting element number 11, something like that. Why? Because index starts from 0. Something like that. So here the index it will be 0, 1, 2. So you cannot even put a 3 here. So when you do that, we get index out of bound exception. So these are some of the things that you need to see. So if you look at it, the program actually crashed with the system.index out of range exception. So in Java, call it index out of bound or whatever. So it will be index out of range exception. Index was outside the bounds of the what? Of the array. Yeah, exactly. Just like that. So that's what will be happening there. So that's why you got this error. That making sense? So I think it's always good to look at this as well, especially when you're doing loops on an array. I think it's always good to also have that. So how do you prevent this so that we do not have the program do not crashes like what we are seeing here? So what you need to do is to remove this, right? Sorry, let's see. Okay, how could I stop this? I'm sure here. Also, I'm sharing and what, blah, blah, blah. Okay, let me just close it here. And then stop it here. Okay. So what I can do here, I wanted to, all right. So what I'm supposed to do is to wrap this inside the try and then catch block, something like that. So maybe I'll have a try there. And then I'll have a what? A catch to catch this exception. Then I will do whatever I want to do inside here. So I'll put the code which tries to generate a what? An exception there. And then when that exception happens there, maybe what I would do is maybe I would do just sorry because I've been coding a lot of languages. I wanted to print using C programming there. Okay, so here maybe I'll just print out there. Let me just print out the basic thing. Let me just leave the issue of exceptions there. But let me just say that maybe index out of bound, something like that. And then let me run this. So let's see what happens there. So it will say index out of bound. So instead of the application or the program being crashed there, so what happens is that whenever this happens, so it will go to the cache and do whatever you want to do there. So if you want to go to the next step or maybe go to the previous step, something like that, it's up to you on what you really want to do inside here, right? But otherwise, if you really want, also, I'm sure you can you can now if I say ex maybe to string there, I'm sure I would make use of this one as well. Let me try to run it. I'm sure I would try to do this. I'm sure it will give me something. Didn't work that way. It didn't work. For me to get this, to get the message out of this exception, I'm sure I will be able to do this to get the message. So sorry, so it's e dot message, not to string, but you get the message there. I'm sure you can also, it's not working, okay. But if you get the message there, I think you should use the message there to get the message there. And then if you print it, so you get the actual message why the error happened. So it say index was outside the bounds of the array. So what you maybe do, maybe you want to print a nice error there. You just say maybe error, and then like this. Then when you run this, then it will tell the user the actual error. What was the error? So it will tell that the error is that index was outside the bound of it, something like that. So basically, that's how you use the try catch there, or that's how you handle exceptions in a program. So you can go and read on exceptions or something like that. But otherwise, that's all, guys. That's all. I don't know if I've got questions, contributions before I go. I don't know if I've got questions and contributions before I go. People do not want to talk. Okay. So if there are no questions, I think I can call it a day. There are no questions, there are no contributions. I'm not seeing any hand